We're starting these notes, section 8.3. In reality, it's nothing new. Nothing new. Okay. All we're doing is distributed property. So it says right here, we already know how to distribute a monomial into a polynomial. Section 8.2. Let's practice this essential skill. So on number one, let's all work through this together. We have a 3x out here in the front. We're going to distribute 3x times 2x. What do I get? 6x squared. Okay. I like writing it below. You don't have to. You can write it on the side if you want. And then we distribute 3x times negative 5. And what do we get? Negative 15x. Thank you. Okay, so that's the answer. 6x squared minus 15. Oh, I forgot the x. 15x. And that's it. If we wanted to classify it, that'd be a quadratic binomial. So let's do number two. We take that negative 7 and we distribute it. Negative 7 times 2x, what do we get? Negative 14x. Let's go negative 7 times negative 5. What do we get? Negative positive 35. Yeah. Man, I keep forgetting the x's. Sorry about that. So anyways, that's it. If I wanted to classify this one, first and last name, what would it be? Linear, because the highest exponent is 1, the degree is 1. Binomial, only 2 terms. So is that difficult? No. So that's pretty easy. I could say that the next section is exactly as easy as that. 8.3, check it out. So multiplying these binomials below is pretty much the same thing as doing the 2 problems above. Okay, check it out. So the only difference between distributing a 3x into a binomial and distributing a binomial into a binomial is that you have 2 terms to distribute instead of 1 term. Like we are used to just having 3x and then distributing that single 3x into both terms and that's it. So what I recommend doing is covering up one of the terms. I want to cover up this guy. And I'm going to distribute the 3x first. Now, we already did that above, but let's just do it one more time. 3x times 2x, what do I get? 6x squared. Yeah, we already did that on number 1 above. And then 3x times negative 5, what do I get? Negative 15x. All right, great. So, ladies and gentlemen, do we all agree we have distributed the 3x? Yeah? Now, it would be nice if that were it, but it's not. We know that we covered up. Whoops. We already know that we covered up. Sorry about those technical difficulties. Anyway, we already distributed 3x. Now we're going to distribute. We're going to move the negative 7 and cover up the 3x. We already distributed the 3x. We don't have to worry about the 3x anymore. So now I need to distribute the minus 7. And I want to use a different colored pen right here. I want to take this negative 7. Even though it says minus 7, I want to treat it like a negative 7. And I want to distribute negative 7 times 2x. And what do I get? Negative 14x. And then negative 7 times negative 5, what do I get? Positive 35. Okay. Now, as you could see, guys, it's the same thing as number 1. Look at number 1. I got this red answer up here for number 1. That was distributing the 3x. And then I got this blue answer for distributing the negative 7. So it's really the same skill that we already knew how to do, just distributing, right? The only difference now is that since I have this polynomial, which is 4 terms, and if I look at it, the 2 middle terms could be combined. Isn't that right, Janisa? The 2 middle terms could be combined. So if I were to combine this 15x, or actually it's a negative 15x, with that negative 14x, what's my answer going to be? Negative 29x. That's right. Negative 29 of those x's. Now, you don't have to show any work. You just, I like to underline or circle or box in just to show that I'm combining. But I do this in my head. You owe somebody 15 bananas. You owe somebody else 14 bananas. You owe a total of 29 bananas, right? Or dollars or whatever you want to call it. Now, the 6x squared, there's nothing to combine it with, so I just bring it down. And the 35 at the end, there's nothing to combine it with, so I just bring it down. And this is it, guys. This is your answer. And that's all this section is. I mean, they put it as a new section, but there's really nothing new that you're learning. Let's look at this one. Whoa, again, technical difficulties. Give me a second. There we go. Okay. So this section, even a binomial times a trinomial or a binomial times a polynomial, it's just as easy. Now, again, the problem here is we're used to distributing just a monomial. We're used to distributing just 2x or just the number 5 or just the number -7. But right here we have a binomial. There's two terms. So it would be easy if it were one term, right? So what we're going to do is just distribute one at a time. It's that simple. So let's distribute one at a time. I'm going to use this little box to cover up one of the terms. But of course, you could just ignore it, right? But we're going to distribute the 2x. So if I go 2x times x squared, what do I get? 2x to the third. Okay. Yeah, 2x cubed. And then how about 2x times 3x? That is positive 6x squared. And then how about 2x times 5? Positive 10x. Now it's important to put that positive right there because it separates the terms. And now we've already distributed the 2x. So now what I'm going to do is move that box over and distribute the other number. So let's move it over, cover up the 2x now, and let's distribute. Whoops. Okay, there we go. Sorry about that. So we already distributed the, let me move this out of the way. We already distributed the 2x. And now we're going to cover up the 2x and distribute the -1. I'm going to use a different colored pen. -1 times x squared, that's simply negative x squared. -1 times positive 3x, just going to be a negative 3x. And -1 times positive 5, that's just going to be a -5. So we have this ginormous polynomial composed of the red terms and the blue terms. Now we just need to combine like terms, okay? So once again, it's this simple. Multiplying a binomial by a polynomial, it's simply distributive property. Just distribute one term at a time and then combine like terms. So I distributed, once again, I started by distributing the -1 first, and then distributing the 2x first, and then distributing the -1. So we end up with this whole polynomial. Now let's just combine like terms. So again, you want to write your answer in standard form. So you want to start with your highest exponential term, and the highest one is what? X to the what? X to the third. So 2x to the third, there's nothing to combine it with. I'm just going to bring it down as the first part of my answer. Then we go for the next highest exponent, which is what? 6x squared. And we're going to combine this guy with what? With the minus x squared. That's right. So that's really like having $6 and owing $1. So what do you end up with? Plus 5x squared. Perfect. Now again, notice when we combine like terms, we don't really change exponents. Adding and subtracting has nothing to do with exponents. Actually, we're just combining the terms that are alike, the x squares with the x squares. And the next terms are going to be the 10x with the minus 3x, like terms. X's with x's, x squares with x squares, numbers with numbers. So 10x, take away 3x. What do I end up with? Plus 7x. That's right. And the last number, my constant, that just stays the same. The -5 comes down. So here's my answer. Anybody want to classify it just for fun? Cubic polynomial. Excellent. Cubic polynomial. Highest exponent is 3. The degree is 3. That's cubic. And there's many terms right here. There's 4 terms, which is a polynomial. So let's take a look at today's homework. So we're only going to do a couple of these. I mean, once you get the hang of it, it's easy. Pick one. 5. Whoa, that's 5. Let's go with number 5. So number 5, we have a binomial times a binomial. Once again, we're going to cover up one term at a time. I mean, let's just go with it. Which one do you want to distribute first? Let's start with the r. R times r. What do I get? R squared, right? Or r to the second power. And then r times -2. -2r. See, it's easy. Now, how about the other term? So I've already distributed the r. I don't have to worry about the r anymore. Next, I'm going to distribute the +1. Now, remember, include the sign that's in front. Let's distribute that positive 1. Positive 1 times r, that's just what? R. And I'm going to write it as positive r. Now you could put positive 1r if you want. You don't have to. And then positive 1 times negative 2, what do I get? Negative 2. So now all I need to do is combine the terms that are alike. Which are the only terms alike? Rosalba, which are the only terms alike? The r's, right? The negative 2r and the r. So if I combine the negative 2r plus r, what do I get? Negative 1r. Do I need the negative 1? No. Not really. So r squared minus 1r minus 2, that's the answer. If you don't want to write that middle value of 1, you could just leave it as minus r. So you could erase the 1 and just leave it as minus r. Either way, it's perfectly fine, and there is no better answer than the other. Okay. You could have the 1 right here, or not. Either way, you're good. So that's ridiculously easy. How about we pick one that's a little more challenging? Which one? How about some 18? 19. 18 is interesting because it has 2 variables. You guys want to try 18 and 19? 18 has 2 variables. So let's do that. That's a little different. So if I go x times 2x, what do I get? 2x squared. And then x times negative y, what do I get? Negative xy. That's right. And now let's distribute the entire negative y times 2x. Negative 2xy. You put them in alphabetical order, right? And then how about negative y times negative y? That is positive y squared. Now, out of those 4 terms, is there any I could combine? Yeah. The minus xy and the minus 2xy. So what do I get? Remember, there you go. Negative 3xy. We are not multiplying, so exponents don't change. Again, there's an invisible 1 right there. There's a minus 1 and a minus 2. You owe $1, you owe $2, you owe $3 altogether. But in this case, we're not talking about dollars. We're talking about the term xy. Now, what about that first term? Bring it down. 2x squared comes down. Bring down the last term, plus y squared. So it's done the exact same way. Who cares if there's different variables, right? Let's go for number 19. You guys wanted 19. That's a binomial times a trinomial. Now, once again, it's kind of like ignoring a value and distributing the w into each and every term, and then you ignore the w and you distribute the 4 into each and every term. Okay? It's really straightforward. You're just distributing one term at a time. So I'm not even going to use that box. Let's just distribute the w. W times w squared, what do I get? W cubed. There you go. W times 3w. 3w squared. Positive 3w squared. Yeah, don't forget that, it's really a 1w times 3w. That becomes 3 times 1 is 3, and w times w is w squared. Last but not least, w times negative 6. Negative 6w. We're all going to ace this test next week, right?
Oh, this is the lesson?
This is the lesson, yeah. Pretty easy. Now let's distribute the 4. We're still halfway done with this. We're going to go positive 4 times w squared. What is that? Plus 4w squared. And then positive 4 times positive 3w. Positive 12w. And then positive 4 times negative 6. Negative 24. Okay, so we have all these terms, and we could combine the... Actually, what is our answer going to start with? What's our answer in standard form going to start with? What's the first term of our answer?
W cubed.
W cubed, that's right. Oh, that's an ugly W, whatever. And then after that, we're going to combine the W squares, right?
Yeah.
So let's combine this positive 3W squared with this positive 4W squared, and we get what?
7W squared.
Positive 7W squared. Okay, and then we need to go for the W's now. We have a negative 6W right here. Actually, let me circle it. And this positive 12W right there, what do we get? Plus 6W. And last, our last value should be our constant, And the only number out there, we don't have to combine it with anything, is just the minus 24. We bring that down, and we are done. Easy. I like setting it up like this and then using different types of symbols to show what I'm combining, like a squiggly underline, or like a circle and a circle, or like a straight underline and a straight underline, right? So I used to I like setting it up like this and doing symbols, but we could do this a slightly different way. Let me show you. Like 21, when you distribute the k times k squared, that's k to the third. K times 3k, what's that? 3k squared. Remember, 3 times 1 is 3, and k times k is k squared. And then 1k times negative 6, negative 6k. Now let me show you an alternate method. Like, I like doing the squiggly underlines, the squares, the boxes, the circles, right? You guys might want to set it up like this. When you do your second term, when you distribute your positive 4, check it out. 4 times k squared is what? 4k squared, right? Now, instead of writing it like this, plus 4k squared, you might want to write it, let me erase it. Let's not write it there. Let's actually write it right below the term that we could combine it with. So again, 4 times k squared is positive 4k squared. And notice I wrote it right below the other k squared. And how about 4 times positive 3k? What's 4 times 3k? 12k. That's positive 12k. Where am I going to write it? Right below the term that I could actually combine it. Positive 12k. And then the last one, 4 times negative 6, that's negative 24. I'm just going to write it out here because I can't combine it with anything. There is no other number to combine it with. So here's an alternate method. If you don't like doing the circles and the squiggly underlines and the boxes that I do, you could set it up like this, and it kind of reminds you of linear combinations. K to the third plus nothing, that's just k to the third. 3 plus 4, that's positive 7 with the k squared. Negative 6 and positive 12, that's positive 6 with the k. And the negative 24 just comes down. So it's totally up to you, whichever method you want to use. I kind of like using the squiggly underlines and the circles and the boxes. But if you want, you could just set it up right on top of each other, ready to combine, if you want. It's totally up to you guys. The answers are on the back of this worksheet. Let's get it done, y'all. Did I just say y'all? Why did I say y'all? Okay. Get it done. Get it done. Guys, it was brought to my attention that number 21 is not the same as on the back side on your answer spot. So let's flip the paper over and look at number 21 on the back side. Okay, so it was brought to my attention that number 21 is incorrect. That's because it's a typo. This is correct. We did do the right work, but if you look at the answers on the back side, they have a completely different question. They have k minus 4, we have k plus 4. They have a positive 5x. They have a positive 5x right here, and we do not have a positive 5x. We have a positive 3. I was saying x's, it's k's. I'm sorry. Anyways, completely different question. We did do everything right. This is the correct answer for this one. However, if you check it on the back, make sure that you understand that they have the wrong question right there.